of ammonia and phosphoric salts, light, heat and electricity present, that a protein compound was chemically formed, ready to undergo still more complex changes. At the present, such matter would be instantly devoured. But this may not have been the case before living creatures were formed.
During the final years of his life, Darwin did little to develop his idea that a primitive cell might have emerged from simple chemicals in the primordial waters of the early Earth. But later in the 1920s and 30s, a Russian scientist named Alexander Oparin formulated a detailed theory about how this could have happened. It was called chemical evolution.
Oparin thought that he could explain the origin of the first life using Darwinian principles. He envisioned simple chemicals combining and recombining to form larger molecules, and then these larger molecules organizing themselves with the help of chance variations and natural selection into the first primitive living cell.
Over the next 3 decades, many scientists worked to develop and refine these ideas as they pondered the questions both Oparin and Darwin had raised. How could life have evolved from simple chemicals? One man thought he knew.
The problem of biological origins has, for a very long time, I would say, has been a real deep interest to me just because of the scale of the problem, the importance of it. Where did we come from? Why are we here? All that kind of question. Probed from the point of view of natural science.
During the late 1960s and throughout the 70s and early 80s, Dean Kenyon was one of the leading chemical evolutionary theorists in the world. And like others in his field, he was trying to explain how life on Earth began through a purely natural process.
In 1969, Kenyon co-authored an important book on the origin of life.
Gary Steinman and